So hello everyone, welcome back to my YouTube channel. So this is lecture 5 of the series Kubernetes 0 to 0. So in the previous videos we have discussed about the cluster architecture, POS lifecycle and this probes. Now today we will discuss about very important thing that are containers. Okay. So what are containers in Kubernetes? So containers are nothing but in general these are the running instances of application, or you can say docker image. Okay. So docker image is there. What is docker image? Docker image is the build of your application code. Okay, now when we run it, then the running instance of that image is called container. Like in previously we discussed, and where is container? This is your pod, container runs inside it. Okay, so containers are basically of three types. Okay, first is init container, sidecar container, and the last is ephemeral containers. Okay. So first we will discuss about this init containers. Okay. So what are these init containers? As the name suggests, init means initially or initialization. So something related to it, right? Like when your application runs, okay, you see here, okay, this is your pod. There may be many containers. Okay, let's say this is your main container. Okay, main application that contains your this main docker image which is running inside it. Okay. So now init containers are init containers run before any of the main containers have run, right? Let's say this, I will explain this example, then it will be better. Okay, so you see this is a YAML file, this is v1, this is pod, this is the name of the pod, everything is there. These are container section. Okay, this, so this container section, and you see this init container section. What are these are array of containers, both are this array of containers. Okay, here and this container section, this contains your main container, or you can say main application will run here, and these are init containers. Okay, so this main app, this is your main application. So when we deploy this code, what will happen? First all these init containers will run, means first this container will run, second this container will run. After that they both have completed their operation, then our main application will run. So init containers run, all the init containers run before the main container starts. Okay, and there are some, like what is the use of it? The use is, like, if you want to include some files or codes that are not present in your docker build of your main application, but they need it, but the main application need it, so we will include in the init containers. Okay, second use case is, you suppose you want to include some startup scripts, your application needs some startup scripts only one time. Okay, when application starts, so you can include those startup scripts as a part of init containers that will run only for the first time. Okay, for the first time, and they will exit also, means they will all the startup completion will be done, and the init containers will be terminated, it will not run permanently. Okay, second use case, suppose you have a database, you want to load some database before your main application starts working on the that data. Okay, so main application needs data, so that connecting to the database, loading the data into your main application, that process can be done by the init containers, right? Okay, so there are some properties of init containers, some of which are, okay, there are some properties. First one is, they always run before main container. Okay, and also always run sequentially. Like here you see there are two init containers. There are two init containers here. First one, second one. So when this will be deployed, first this init first container will run, execute whatever command is there, and will terminate. it will be successful and then terminate. After that, this second will container init container will come up, it executes some command and then will terminate. Okay, and the next is these containers always terminates terminates, or you can say always leads to success. Okay, or you can say always completes, always leads to completion. In the previous video we discussed about pod's life cycle, right? A pod is in waiting state, pending state, or running state, terminated. These states are there. Okay, so if main application, for your main application, it always needs to be in a running state for application to accessible by the user, or okay, this always needs to be running. But what about this init containers? They needs to be completed. We don't need to be always running. Like the startup scripts are there, they will run and will close. We don't need to run them always. Okay, so this is always terminated. For this region, these init containers don't have pod's life cycle. So whatever the pod's life cycle stages we have discussed in previous video, they don't have it. Okay, what were the pod's life cycle? That pending, running, succeeded, these, so they don't have. And also they don't have probes. They don't have what were the probes we discussed, right? So probes were used to check the application health of the application that is running inside the container. Three probes were there: liveness, readiness, and startup probe. If you have not watched, please watch the previous video. Okay. They don't have probes. Like if these init containers are always leads to completion, then logic is they don't need the probes because they are not always in a running state. They always leads to completion. Okay. Last point is, okay, they always leads to completion, but what will happen if some error occurred in the init containers? Like when we run this first init container success, then let's say this container fails, second init container fails, then what will happen? Your main application will also not run. This will also not run. So the condition for running your main container is all the init containers must be successful. If any one of them fails, then the kubelet will not start the main application only. Okay. So this is all about init containers. Now we will discuss about second thing, that are sidecar containers. Okay, so sidecar containers, as the name is suggesting, side. Okay, so say we have our pod. Okay, let's say if we divide it. Okay, these were some init containers. Okay, these were some init containers. When we deployed, they start and then they exited. They're completed now. And there are some main application. Let's say this one is your main application container. Okay, so for main application to run, generally they don't require any sidecar containers, but let's say if require some other containers, like for monitoring purposes you like some other container to record its logs. Okay, like you want to separate the logic. Main application only contains business logic. Okay, now some other containers you need, some other resources you need to support this main container. Let's say this one is a some logging. Let's say for logging. Okay, for logging purposes we included this. So the main function of this is that it will continuously captures the logs of the main container. Okay, some other component are also there. So like sidecar containers play a supporting role, we can say. Okay, so these play a supporting role to main container. Okay, so this is about sidecar containers, and everything is same about sidecar containers, main container. Only init container was different, that they don't have life cycle or they don't have probes. Sidecar containers have pods life cycle, right? Have probes because they are continuously running. Okay, and they are not exited. They continuously run. Means all the life cycle are there, so they are in a running state. Okay, if it fails, the main application will fail. Okay, but it always needs to be in a running state, not like the init container that it needs to be stopped or means completed. Okay, so this is much about sidecar containers, and if you want to look at the YAML code, suppose here, okay. Okay, okay, let's say this here, uh, in the containers only one was there, only one container is there. Like, if we add one more container here, some logic is there, one more container, same code, some different image, okay, and that is performing different. So this will act as a sidecar container to the main container, okay. So this is just a concept. So sidecar containers mainly play a supporting role to the main containers. So, so this is much about this sidecar containers. Now we will discuss about ephemeral containers. Okay. Ephemeral containers. Okay. Okay, so ephemeral containers, I would discuss the main use case. Ephemeral containers are containers that are particularly used for troubleshooting purposes, right? For troubleshooting or some you can say diagnosis, okay, diagnosis purposes. Like you have a pod, right? Now some app is running. This is your main container. This is your main container. Application is running fine. Now on some random day, some issue occurred. Any random issue occurred, okay, some issue occurred and it stops running, it starts failing. Now what are the cases how you can debug this situation? You want to know what is the error, okay, you will check the logs, okay, but if the logs are not completely fine, you need to debug this container, you want to get inside this container. So basically you can't get inside this container if this is failing. So important thing is you can only get inside the container and check the file system of it or logs of it only if the container is in running state. If this is failed, you can't get inside the container, okay. And how you get inside the container, just some information, in the first cluster architecture video I have discussed about this kubectl, right? So this is a command line tool provided by Kubernetes to uh, to manage the Kubernetes by command line. Like there are two methods like for managing. One you can do by YAML file configuration, and second by this kubectl. Okay, so kubectl also provides some APIs that interact with the directly with the Kubernetes. Okay, so you want to get inside this container, you use this kubectl command. Some kubectl exec command is there. By that you can get inside the container, but your main application is failing. You can't get inside it. Okay, so what you can do is, so in this case ephemeral containers comes as a rescue. What it does is it it can replicate the issue, means suppose this error occurred, okay, now you want to resolve it. So if you do any change to these YAML files, it will redeploy the again, okay. So ephemeral containers means on the running instances you don't want to upgrade anything or don't want to restart the server, and you want to check what is the error. So that is the use case of ephemeral containers. How you will use it? By command line only. So Kubernetes currently doesn't support, okay, I will write it doesn't, Kubernetes doesn't support YAML manifest of ephemeral containers. Right? So YAML manifest means you see here, na, this is the YAML manifest, means YAML code of the application that you are deploying. So you it for by YAML manifest you can't create the ephemeral containers. Only way to create the ephemeral containers are by the kubectl command. Okay. So you did see this command like kubectl debug -it my pod. This is the pod name. This is the image name. That container will require an image name, right? So this is the image name. This is the target. If this container has failed, this is the target container and bin. Okay. So this will debug. It will give the logs of this logs, or it will run in a debug mode that you can troubleshoot or diagnose what the issue has occurred. Okay. So ephemeral, as the name suggests, also that these are not permanent in nature. They are only used for troubleshooting or diagnosing purposes. So hope you understood the containers. In the next video, we will discuss about services and gateways and other things on Kubernetes. That is important thing. And okay, so hope you are liking my content, and if you are liking, please do subscribe and please do comment and like the video. It gives the motivation to proceed and make such videos again. Thank you so much.